Section 4 deals with the slope of straight lines. The slope is basically how steeply the line rises or falls across the page. We use the letter M to represent the slope. The slope is defined as the rise divided by the run. And the rise, of course, is the change in the y values. And when you see the little triangle like this, that represents change in. So this is the change in y. And the denominator part represents the change in the x. In other words, as we move from one point to another, how much are we going up and how much are we going across defines our slope. So if we have 2 points, we can find the slope, the rise over run between the 2 points, simply by taking the difference in the y values and the difference in the x values. And so what you see here is we have 2 points, -3, -1 for our first point, 3, 3 for our second point. Here is the -3, -1, -3, -1. Here is the 3 and 3. And so y2 minus y1, note when we subtract a negative, it becomes an add. So 3 plus 1 is 4, 3 plus 3 is the 6, which we can then reduce to 2/3. What that means is, at any point on this line, we can start and basically go up 2 over 3, and we will be back to the line. Up 2 over 3, up 2 over 3. This gives us another way of graphing straight lines, because if we have any point on the line and we have the slope of the line, then we can get additional points simply by basically the top part is going up or down, down if it's negative, and the bottom part is going across. This leads to what is called the slope-intercept form of a line, where again the M is the slope and the B is where it crosses the y-axis, the y-intercept. We can rearrange equations so they go from what's in the standard form. Here is an example of a standard form. Anytime it's ax plus by equals c, where a, b, and c are numbers, you can rearrange it. So here we've rearranged it. We first moved the 2x to the other side. So it's now -2x, and then we divide everybody by the 3, and we end up with it now in the slope-intercept form. Here is our slope. Whatever number, including the sign, that's in front of the x, that's our slope. And then if there is another part, that is where it crosses the y-axis. And as I said, we can, in fact, graph a line simply by knowing a starting point and then what the slope is. So in this particular case, if we go down here, this point would be 0, -4. So again, the origin is 0, 0. So x was 0, so we don't go left or right. We go down 4. And then from that point on, since it's negative, we go down 2 over 3, down 2 over 3. We have a series of points that line up. We can draw a line through them and graph our line. Now, we, in the last few sections, got introduced to function notation. And so if, instead of writing y equals mx plus b, we write f of x equals ax plus b, then we have what is called a linear function. The function for a straight line, depending on whatever the values a or b are. And we can, of course, graph linear functions by making t-charts, for example. We've introduced the idea of having a t-chart. So down here we have some examples of graphing where we've done some t-charts. You can also take a little bit of a shortcut by finding the X and x is 0. The x-intercept is where y is 0. And, we take an equation. Well, if the y part's 0, then it's just 5x equals 10. If the x part is 0, then it's just negative 2y equals 10. Those are easy to solve to give us what our various outputs would be. So those are the basics of this section. Let's now look at some examples. So if we have 2 points, we can find the slope between the 2 points by using our slope equation. M equals y2 minus y1 over x2 minus x1. And again, it doesn't really matter which one you say is number 1, but I'm basically going x1, y1, x2, y2. And so in this case, I'm going to have 8 subtract the 3, the second numbers in each ordered pair, over 7 subtract 2. This gave me 5 over 5, which is 1. So the slope is 1. Here's the second example. Again, m equals y2 minus y1 over x2 minus x1. So here I'm going to have 6 subtract a negative 1, and then 4 subtract a negative 2. 6 plus 1 would give me 7. 4 plus 2 would give me 6. And so my slope is 7 over 6. Now, if instead what we have is a line and we want to find the slope of the line, then basically all we need to do is find a couple of points on the line. So, for example, if we're going to start off with A, so A is going through the y-axis right there, and then I note that it goes through this point and then this point. And so the pattern looks to be down 2 over 1, down 2 over 1. So for line A, it crossed the y-axis at negative 1. My slope is negative 2. By the way, even though it's often written as a fraction, any whole number can become a fraction if I simply go over 1. And then in function notation, I will have negative 2x subtract 1 as my linear function. For B, it appears to be crossing right here. And we're not going to worry about things like, well, is it really right on the point or is it just a tiny bit off? Our squares are so small that, we want to do a little bit of rounding in that sense. And let's see, we go through another one that appears to be right here. And then appears to be right there. And so let's see, we're going 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. So for line B, where it crossed was at positive 2, and this time the slope is, again, we went up 1, 2, 3, 4, we went across 3, and so now my function looks like 4/3 x plus 2. And again, just as a point of clarification, please note that the x is not included as part of the slope. It's just whatever the number is that's in front of the x. If there is no number in front of the x, then that would be a 1. All right, so we had some lines. We figured out what their equations were, their linear functions. Now we have some equations, and we want to go ahead and find their slopes and graph them. Well, here is my slope, 4, and here is my y-intercept, which is at -8. So if I want to do a graph, I'm just going to simply start at -8. So here's -10, so -8 will be right here. And then, since my slope is 4, I'm going to go up 1, up 4, and over 1. Again, the rise over run. So 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Again, usually 3 or 4 points is sufficient. And then approximately there for part A. This would be the y equals 4x subtract 8. Now here, this is in standard form, so I'm going to rearrange it and have -6y equal -8x plus 12. Then I'm going to divide everybody by the -6, so y will equal -8x over -6 plus 12 over -6, which gives me 8 over 6 is 4/3, and then subtract 2. So this one is going to start, let me do it in a different color. This one is going to start at -2, and then its slope is 4/3, so up 1, 2, that's 4 over 3, and then up 1, 2, 3, 4 over 3, up 1, 2, 3, 4 over 3, and again they should all line up. Rulers really help, otherwise it's kind of easy to be sloppy in your line, and so here is the 8x minus 6y equals 12 for the second one. All right. For the next example, it says graph using the X and Y-intercepts. So remember, where the X-intercept, Y is 0. For the Y-intercept, X is 0. So I'm going to make some little T-charts to see how it looks like a T. And then X and Y. And so first, let's make X 0. Well, if X is 0, then I'm just left with Y equals 6. So there's 1 point for my line. And now I'm going to make Y 0, which means 3x equals 6, which means x is 2. Now, that's enough to graph the line with, but I do recommend doing at least one more point to make sure that things line up. So if I make x3, then I would have 9 plus y equals 6. Move the y over, so y would equal -3. And so in this case, if x is 3, y is -3. And so here we have 2, 0. And 0, 6. And 3, -3. 3, -3. So 3 points that we're lining up. And the second one here, let's do the same thing. Okay, make a little t. X, y. So if x is 0, then I'm left with 2y equals 8, so y is 4. If y is 0, then I have negative 4x equals 8, so x is negative 2. And then just to put in a third value, I'm going to let x equal 2. So that'll give me negative 4 times 2, which is negative 8. Bring it to the other side, becomes a positive 8, so 2y will equal 16. Y will equal 8. And so let's see, 0, 4, right there. Negative 2, 0, right there. And 2, 8 up here. And so there is the second one. 2 points from the intercepts. Again, where x is 0, it's the y-intercept. Where y is 0, it's the x-intercept. All right, so our last examples here of graphing straight lines. Note that this one here, here's my m, but there's no b. So that means the b is 0. Well, if the b is 0, then it's going through the origin. My slope is 3, so from that point on, I'm going to go up 3 over 1, up 3 over 1, up 3 over 1. And so here is part A, and of course, I can go in either direction as far as I would like. Now note, in these two here, let's look at the first part, y equals 7. There's no x part at all. In fact, if you want, there's just a b, okay? Now, the thing to note for this first one is there are no x's. X could therefore be anything. In other words, x could be 0. That would in fact be the case if the 7 was the y-intercept. Well, but x could be 10. Y still has to be 7. X could be minus 5. Y still has to be 7, because that's the only thing I know for sure is that y is 7. Well, when I graph those, first let's do 0, 7. So 1, 2, there's 0, 7. Well, over here, that's 10, 7. And over here, that's negative 5, 7. What, in fact, we end up with is a horizontal line. So anytime you do not have any x in your equation at all, just a y, you're going to end up with a horizontal line. In a similar form, the second one, x equals negative 5, well, that tells me what x is, but does not tell me what y is. So, in fact, I can make y anything I want. And so when I plot those, x is negative 5 and 0. Well, that's going to be right here. X negative 5 and 10, that's up there. X negative 5, y negative 5, that's down here. And as you see, they all line up vertically. And so anytime we get just an x equals, we will have a vertical line. So, various ways to graph straight lines depending on the information that we're provided. Okay, a little bit more and then we'll be finished with this section. What if they tell us the slope and the y-intercept? And what we want to do is write out the equation on lines. Well, again, we're looking at something that has that form, and really that number right there, that's the b. Remember, x, y, so anytime x is 0, that's where it's crossing the y-axis, so that's my b. So the equation here would simply be 4x plus 3. Here we're being explicitly told what the m and the b are, and so again, following the slope-intercept form, mx plus b, simply going to put in -5 for the m and -2 for the b to get my answers. Now, problem 7 here shows you the nice part about using function notation instead of y equals for every equation, because now I can separate the two simply by their names. So here is f of x, here is g of x. They still have the slope-intercept form, so in the first one here, m is -3, b is 6. In the second one, m is -3/5, b is -6. So let's go ahead and do the first one. I'm going to start at 6 on the y-axis. Again, x, y. And my slope is -3, so that's down 3 over 1, down 3 over 1, down 3 over 1. Do a couple of them. And so here is f of x. So really all it's showing you is we used function notation instead of xy notation, if you will. Now for the second one, we're going to start at -6, so that would be here. Now here my slope is -3/5, so down 3 over 5, down 3 over 5, down 3 over 5, and so this one. There's my g of x. In this next example, again, considering instead of y equals mx plus b, function notation f of x equals mx plus b. So when they put it to us, this is really the x part, okay? And then this is the f of x, which, again, is another way of describing the y part. The x part, the y part. So essentially, even though it looks very different, I basically have 2 points. It's just it's written in function notation instead of xy notation. But I can still use my slope formula to figure out my answer. So in this case, I'm going to let this one be the number 2 and this one to be the number 1. Order doesn't matter. And so my slope will be 410, subtract 250, over 31, subtract 25, or excuse me, 15. Hope to have myself there. Well, that's going to give me 160 over 16, which is 10. Now, that will give me f of x equals 10x plus b. Okay, so how do I find the b? Well, I use one of these two examples. So, for example, it says if X is 31, the output is 410. So 410 has to equal 10 times 31 plus B. So 410 equals 310 plus B, which is going to lead to B is 100. I could have done it with the other point as well. Bottom line is my function is going to be 10x plus 100. Now, this last example is really doing the same thing we just did in part B for number 7, but it's written as a word problem kind of form. So, Janie and Julie went to the carnival. In addition to the admission, Janie bought 20 tickets and Julie bought 36 tickets. And so I'm going to call this X1 and this over here X2. Janie paid a total of $15. So I'm going to call that Y1. And Julie paid $23, Y2. Find the linear function f of x equals mx plus b, where x is the number of tickets. So notice 20 ride tickets, that's my x. And the f of x represents the cost. So then for Janie, basically 20 tickets for $15. And for Julie, 36 tickets for $23. And now note, if I just raise a bit, now I'm right back to what I was doing up here. I can go ahead and find my slope. So, again, y2 minus y1 over x2 minus x1. So, we've got 23 subtract 15 over 36 subtract 20. That's 8 over 16, which says m is 1/2. Now, my general form is f of x equals mx plus b. So, I'm going to use this first one here. Remember, the second number is the cost. F of x represents the cost. So 15 has to equal my slope 1/2 of 20, the number of tickets, plus b. Well, 15 equals half of 20, which is 10. And so b is going to equal 5. And so my function is that, which basically says the admission was $5, and then it cost them 50 cents per ticket. And so there you have section